Hello everybody, today I'm going to show you how to determine the direction of a parametrized curve using calculus and geometry, as well as a little bit of algebra into finding the trajectory as well as the progression of a parametrized curve. So here we have a question. We have x equal to 2 plus 3 times cosh t, and we'll have the y is being determined by minus 1 plus 2 times sinh t. Okay, so now we will determine what is the trajectory is, and how we can go ahead and apply calculus into finding this particular trajectory direction. Okay, so now we have x in terms of cosh and y in terms of sinh, and we know that cosh and sinh has some identity, has some connection with each other. So the first thing you might think of is cosh of t squared minus sinh square t will be 1. Alright, so this is a very famous and very popular identity, as well as the connection between cosh and sinh. You can go ahead and you can derive it, and if you don't remember this identity, you can go ahead and derive it. It's just the cosh that is cosh. You know that cosh equal to e to the x plus e to the minus x over 2, and sinh is just e to the x minus e to the minus x over 2. When you square these up, these terms will cancel. These terms will cancel, and you're left with the cancellation, and 2 divided by 2, you get the 1. So that is a very useful tool to have. All right. So now we keep in mind that connection, and we're going to do something about the x and y. We make that so that it stay in that format. So we somehow normalize it, and we try to give it x and y the connection same as cosh and sinh would have the same connection. Okay, so we go ahead and do it. So now we try to put cosh on one side and x on one side. Alright, so we may transform this as x minus 2 over 3 will be cosh equal to cosh t, right? Alright, and from previously we wrote it cosh square minus sinh square, so that y, so we can try to transform this y plus 1 divided by 2 squared equal to 1. Alright, so in the first hand we look at this, this look familiar, right? But turn out this is a hyperbola, right? With the hyperbola opening, or the ruling parallel to the x-axis, because x is the minus agent. Alright, so so now we have this. Well, it doesn't really say anything, because when we so let's go somewhere like this. We have x minus 2 over 3 squared have to be bigger than 1, because this entity is bigger than 0. This minus this is equal to 1, right? So which it implies that this have to be greater than 0. So therefore x minus 2 over 3 squared have to be greater than 0, greater than or equal to 0, or greater than 1, or greater or equal to 1. Alright, so now we may transform it. So this implies that x minus 2 absolute value, because it's a square, have to be greater than or equal to 3. Right? And this implies that that x have to be, when you put it out, x have to be greater than, x minus 2 greater than 3, or x minus 2 have to be less than or equal to minus 3. Right? So if you do, you put the numbers on one side and x on the other side, this is x had to be greater than 1, right? So this top one right here, you have x is greater than or equal to 1. This is plus I'm sorry, is 5, right? Put a 2 over there, 3 plus 2, that's 5, right? X minus 2, put over there, so x had to be less than minus 1, alright? So x less than equal to minus 1, alright? So, alright, so we can go ahead and draw the hyperbola, but before we do that, let's try to figure out what is the asymptote. You need the asymptote to figure out what's the frame for the hyperbola. Well, you see this is y has a 2 down here, x has the 3 here, so you know that the slope of the asymptote is 2 over 3, right? And this thing equal to so let's put it that way. Let's say let's put it equal to 0. We're trying to find the asymptote anyway, right? So the extreme of the hyperbola. So let's try to put the 0 anyways. So you would have x minus 2 over 3 equal to y plus 1 over 2. Alright, so therefore you have y plus 1 equal to 2 over 3x minus 2. So this is the equation of your asymptote. And you go ahead and draw it and see what it looked like, right? So now we have the asymptote, we have the restriction for x, we know it's a hyperbola. Go ahead and sketch this. The first right, so you have the minus 1, x is equal to minus 1, right? Here, x is equal to 5. So, you know, x is going to be bigger than that, or it has to be less than minus 1. Right, so 2 points here. So now you put it in, you put x in, x equal to 5, what is y equal to? Well, x equal to 5, meaning that cosh had to be x equal to 5, meaning that cosh had to be 1. But cosh is 1 only when t is 0, right? So t is 0, and we know this is a parametrized curve, meaning it's a unique curve. And this is not like it had multiple curves on the same coordinates, right? It's only have one curve for any particular t. So as it's defined. So you put t equal to 0 in here. That's sinh 0. That's 0, right? So sinh t when t equals 0, that's 0. We have y equal to minus 1. So therefore we have it. Y equal to minus 1. 0, so that we have the point here when x equal to 5. When x equal to x equal to 5, and when x equal to minus 1. Right? Same here. When x equal to minus 1, this thing is x equal to minus 1. Put it in here. What do you have? We have this 1, right? We have a 1. So there you go. Cosh t is 1 when t equals 0. Poke in 0. Y is minus 1. Alright, so we have this. Well, we have the asymptote. Before we said that the asymptote is right here, right? We have y plus 1 equal to 2 over 3 x minus 2. Alright, this is the asymptote. 2 over 3 x. Let's put x equal to 3. So this slope, but you bring it a little bit down because you plus 1, right? So you're going to bring it down here. So somehow you have a curve that looks like this. Hyperbola, right? Just a sketch, just a rough sketch, so that we know what we're dealing with, right? Alright, so that's the asymptote that we have. This is the equation for the asymptote, right? So we have this be plus or minus because it's go like that, right? So plus or minus the slope, plus or minus 2 over 3. Okay, so if it's a plus, it'll be like this one. Be a minus, it'll be this one. Okay, so now we have a rough sketch like that. But which curve are we talking about? Are we talking about this curve? Or are we talking about this curve, right? So next part we're gonna determine how that we may discern which from which one is we choose. Is it this curve prolonging this way, or this curve prolonging the other way? Alright, thank you very much.